Hello guys, good day. So again, we're here to discuss another new topic. So under Module 5, so ang pag-aaralan natin ngayon is yung tinatawag na Curvilinear Translation or mas kilala sa tawag na Projectile Motion. So first, under Curvilinear Translation, so in this session, you will get to know more about the concept of dynamics of rigid bodies and other engineering science. And by the end of this session, you should be able to, so for the first one, so to know the definition of a projectile and to use concepts of force and inertia to explain the manner in which gravity affects a projectile. Okay? So we will define what is projectile and paano ba ina-apply yung kanyang concept pagdating dun sa gravity and so on. Wait lang ah. Where's the size? And then let's add this to the so ayan. Okay, so to know or define a projectile and to use its concept in the manner in which gravity affects a projectile. Okay, so dalawang bagay lang naman yung gagawin natin dito. Okay, so ang una, yung projectile kasi, it's a combination of rectilinear and free fall bodies. Okay? So, when it comes to rectilinear, or ang mangyayari kasi dito ngayon, yung pagkakahagis ng isang bagay or pagkakatapon sa kanya, it will act at a certain degree. So, parang yung concept lang din ni component of a force. So, meron siyang x component and meron siyang magiging y component. So, yung x component, dito papasok yung rectilinear translation. So, tandaan nyo lang na kapag yung x component, constant yung acceleration. There's no acceleration and there's a constant velocity. So, wala ang acceleration, constant lang yung velocity mo. Or in short, yung distance na matatravel niya is just equals to the product of the velocity times the time. For the free fall, ayun nga. So, since most of the time naman, ang pagkakahagis mo is upward or at a certain degree. So, yung gravitational acceleration mo, since opposite siya sa direction ng iyong initial velocity, so, ang mangyayari, negative yung ating gravitational acceleration. Just like the principle or yung concept na tinuro ko before sa inyo, under the free falling bodies. Okay, so for number 2, to be able to describe the horizontal and vertical components of the velocity and displacement of a projectile. Okay, so tapatan lang to. So again, tuturo ko sa inyo dito yung dalawang approach. Una is using the derived formula and yung pangalawa is using the combination. So when I say tapatan lang, so for example, meron ko ditong projectile motion. Okay, so yung displacement na makukuha niya dito, ayan. So let's say that this is x. So yung height nito or yung y, noted by y. So ang time niyan, dapat pareho lang. Yung time na nakapunta dito siya sa x and yung time na narating niya itong point na to, yung height na yan. So that should be equals with each other. Okay, so isa yan sa relationship na pag-aawaan natin. So usually naman ang hinahanap dyan is itong mga distances na to or yung displacement and yung height na narating niya at a certain time. Okay, so pwede rin naman na velocity yung hinahanap, yung maximum height, and tandaan nyo lang guys na kapag narating nyo yung maximum height, yung y component ng velocity is equals to 0. So, ano lang din siya, kapareho lang din sa ating free fall, di ba? At when it reach its maximum height, momentarily, parang tumitigil yung bato natin. So, parang ganun din yung application niya dito. And dito naman sa x, again, gaya nga nasabi ko, and yung velocity niya is constant. So, therefore, yung acceleration natin is equals to 0. Okay? And para naman dito sa y component, yung acceleration niya dito is yung negative g mo lang or yung negative ng gravitational acceleration. Okay, so again, basahin ulit natin. For number 2, so to be able to describe the horizontal and the vertical components of the velocity and displacement. Next, number 3, to be able to numerically describe the various features associated with a projectile trajectory. So, the components of displacement, the velocity, and the acceleration. So, dito papasok nga guys yung ilang set ng formulas. Ipapakita ko rin kung paano na-derive yung mga formulas na yun. So, gaya ng una, just in case lang na makalimutan, so there's a way para ma-derive yung mga formulas na to. And to avoid nga na madagdagan yung sasauluhin nyo, so dito ko nga ituturo sa inyo yung diskarte na paghahaluin lang natin yung free fall at saka rectilinear translation. Next, number 4. So, to use kinematic equations to analyze and solve horizontally launched projectile problems. And for number 5, to use the kinematic equations to analyze and solve the angle-launched projectile problems. Okay, so ito yung mga objective natin. Now, let's now proceed with the lecture. So, basahin muna natin siya. Okay, so basahin natin yung lecture part. So, for the first paragraph. So it says here that a motion in a plane is also referred to as motion in 2 dimensions. So example of these are circular motion and yung projectile motion. Ayan. So ilan yan sa mga example. Next, so for the analysis of such type of motion, so ayun nga yung projectile motion. The reference point will be made of an origin of 2 coordinates axis x and y. So ito yun. Ito yung reference point natin. So starting at an initial point of O. Okay? So one of the most common example of motion in a plane is projectile motion. So ano ba yung projectile? So guys, ang projectile, it follows a parabolic trajectory. So just like in this problem or in this diagram, so, kung mapapansin nyo, yung trajectory niya is in a parabolic shape. So, it refers to an object that is in flight after being thrown or projected. In a projectile motion, the only acceleration acting is in the vertical direction. So, doon lang daw sa y direction o yung vertical component ng velocity, doon ka lang merong acceleration. Which is, yun nga, yung acceleration due to the gravity, or that is yung ating G. And the horizontal component is at constant velocity. So again, when we say constant velocity, yung acceleration natin dito, or yung A natin, will be equals to 0. Okay, so yung A sub x, or that represents the acceleration in the x direction. So 0 yung kanyang acceleration. So equation of motion therefore can be applied separately in the x and y axis to find the unknown parameters. Okay, so i-analyze muna natin guys yung diagram. So again, meron ka ditong velocity at acting at a certain degree, theta. So meron kang x component niya denoted by b sub o, x. And meron kang b o, y. So i-zoom ko lang ng konti guys. Ayan. So, para makuha yung BOX, okay? So, gagamitan mo siya ng trigonometric function. So, paano nga makukuha yung x component ng isang velocity? So, yan ay equals lang sa v multiplied by cosine theta. And for the y component, so that is simply equals lang sa v multiplied by sine theta. Okay? So, at point A, guys, yung h na yan, ito yung maximum height na pwedeng ma-attain nung trajectory ng iyong projectile. Okay? And at point A, so yung y component ng velocity dito, so again, kapag nandito siya, meron pa rin yan guys na ano, na yan. So ito, so i-denote natin as BAY, pinakita na pala. So, yung y component niya is equals to 0. So, ito nga yung sinasabi ko, once it reaches its maximum height, yung y component niya is equals to 0. And yung velocity dito, ayan, yung VAX. So, equals pa rin siya do sa initial velocity, kung saan equal siya sa v cosine theta. And yung resultant na velocity niya, yung v sub a, is equals na lang din sa VAX. Kasi nga, since yung iyong VAY is 0, ito na yung para magiging resultant mo. Kasi kung i-analyze mo nga naman, since wala ka ng VAY, ang only force na nagre-represent sa kanya is yung x component. So, kung kukunin mo yung resultant niyan, yung dalawang force, di ba, paano nga natin makukuha yung B sub O dito? Di ba ito ay equals lang sa square root ng Vx squared plus By squared. So, ganun lang din dito. Since yung iyong, para makuha mo yung VA, wala ka nang VAY. So, yan ay equals na lang sa, sige, sulat na rin natin. VAY squared plus BAX squared. So, since ito is equals na sa 0, so, squared tapos square root, di ba ang VA is just equals na lang sa VAX. So, ayan yung sinasabi niya. Or yung resultant na velocity mo is nakalapat na lang din along the x-axis. So, next, ayan nga, ito yung kanyang h, ito yung maximum height. And yung r mo, ito yung maximum range. So, sa maximum range naman, guys, ito yung pinakamalayong pwedeng marating ng isang projectile trajectory natin. Okay? So, ito yung pinakamalayong distance na pwede niyang maabot. So, ito is denoted at point C. Ayan. Kung makikita nyo sa figure. And, kapag kinuha yung component niya, ito. Ayan yung ating V sub C. Okay? Kung saan, if it's on a level surface, so, parang bumalik lang siya doon sa iyong original point. Okay? So guys, ito is considering na wala kang meron kasing case na meron ka ditong opposing velocity. For example, mayroong wind dyan. So ibang usapan yun. So mas malalim na discussion yun. But anyway, try nating ma-discuss siya. Or maghanap akong example kung saan meron kang wind. Okay, so ayun nga. So yung V sub C mo is just equals lang din sa inyong initial velocity. So, yung V sub x mo dito, again, sabi nga doon sa condition mo, yung velocity mo is equals lang sa all throughout its motion. So, kahit nandito siya sa point na to, dito sa point na to, dapat, at the end of the day, pareho lang yung velocity, yung x component ng velocity. And then, V sub y. So, since guys, pababa na yan, so, yung final velocity niya pagdating dito is equals lang sa negative ng V sub OY. Kasi opposing na siya sa direction ng ano. So, same lang, yung tinuro ko sa inyo. Once na lumabag ka sa direction ng initial velocity, negative na siya. Okay? So, at point B, ito siya. Ayan. So, etong Y na to, so this is the height at any time t. Okay? So, maaari itong B ay nandito sa kabila, yung bago pa niya ma-reach yung maximum height niya, or pwede rin nandito yung once na nalampasan niya yung maximum height niya. Okay, so itong bing to represents at any point dito sa iyong trajectory ng iyong projectile. Okay, so yung range niya is represented by x, and then yung v sub x niya, so denoted by b sub v x is equals to, again, equals lang siya dun sa initial velocity. And then yung v sub y, ayan. So ito is ma-compute naman. So usually ito ay yung final velocity, which is unknown. Pwedeng hinahanap sa problem. So again, since pababa yan, so negative yan. Pero still hindi natin alam yung value. And then ito yung VV or yung resultant yan. Okay, so ito ng mga equations na to, ito may derived equation siya. So ipapakita natin. Also for the x. Okay, so i-browse natin pababa. Ito yung guys yung mga list ng formula. So again, to get the x component. So ito lang din siya, guys. Ayan din. So kunin ko lang yung highlighter. Yung pagkuha ng component ng mga velocity. So at any point p, so for the x component of motion, the acceleration is 0. Therefore, constant velocity. Thus, ax is equals to 0. So wala ang acceleration x. So if you're going to solve for the distance x, eto. So since constant yung velocity niya, so that is equals lang sa vox or yung x component times the time t required para ma-reach yung distance na yun. So yung time na yan is equals lang din sa time dito. Okay? Para ma-reach yung height na yun. So saan ba nanggaling to? So again guys, Di ba meron tayong formula na yung S is equals to VOT plus 1/2 of AT squared. So since ito, papalitan lang natin tong S in terms of X. Ayan. Anong kulay ito? Pula. Okay? And yung VO mo, so this will be represented as VOX o yung X component ng velocity. And knowing na ito nga, acceleration is equals to 0. So ayan lang yan. So dyan nakuha yung formula for the distance X. So ganyan lang kasimple, and it was derived using direct linear translation, assuming that the acceleration is 0 since constant velocity. Next set of formulas, so for the y component of motion, so ay nga natin, or yung acceleration in y direction, is equals sa negative g. So notice that the first formulas that follows are taken from motion with constant acceleration, or ito nga yung mga formulas na ginamit natin for the free falling bodies. So mapapansin nyo naman, ayun nga, kamukha lang ng ginamit natin. So yung bb sub y dito is yung final velocity at the point reach at point B. So ito siya, BBY. And yung BVX natin. Okay? So these are the formulas. So sabi ko nga, kamukha lang din siya ng mga equation natin na VF is equals to VO. So plus minus GT. So since pababa nga yung ano natin, so pwede na nating alsin yung plus. So that is minus na lang. And then ito, so y is equals to VOT. And then minus 1/2 GT squared. And then final velocity squared is equals to VO squared minus 2AS. 2GS. Ayan. So magkamukha lang, diba? Actually, ito na rin naman talaga yon. So binase lang natin sa figure. Okay, next. So yung y is equals to x tangent theta minus gx squared. And 2VO squared cosine squared theta. So guys, ito yung derived formula na sinasabi ko. So saan ba natin ito nakuha? Okay, so coming from this equation, ayan. So guys, ang mangyayari kasi dito, if we are going to solve, ang gagawin kasi natin, parang pagre-relate natin yung time. Kasi nga, yung time para ma-reach na yung distance x, and yung time para ma-reach na yung height na y, is equals lang sa isa't isa. So if we're going to solve for t, dito sa first equation natin, so that will be x is equals to VO x. Okay? And then using this second equation, yung y is equals to VOYT minus 1/2 GT squared. So ang gagawin natin dyan, isa-substitute natin yung time t with this equation. So ang kakalabasan ng equation mo is ganito. So yung y is equals to VOY and then multiply by time, so magiging x all over v sub o x. Okay? So minus 1/2 of g times t squared. So ito, so that will be x all over VOX squared. Okay? So ano nga yung nahabol nating equation? So ganito dapat yung mapapalabas natin. Okay? So knowing that yung equation mo for VOY and VOX, so itaas ko lang guys ng konti. Ayan. So since equal sila dito, okay, so we can substitute these values. Ay, sorry. Eto. So papalitan natin yan, itong mga VOY and VOX mo. So ang equation natin ngayon is magiging ganito. So yung VOY magiging VO cosine theta, so multiply by x all over, VOY pala yung nasa ibabaw. So ito guys is magiging sine. Pambura. Ayan. So this is sine theta, and then yung ilalim, so VOX, or that will be equals lang sa VO cosine theta. So I can cancel out these two terms. And then ito, di ba sine over cosine will be tangent? So pwede ko siyang palitan ng tangent theta. Okay, so ano nga hinahabol nating equation? Ayan, so nakuha na natin tong part na to. And then minus, so guys, dito na tayo sa minus 1/2 of g multiply by x again over, so yung VOX mo, papalitan mo lang ito ng VO cosine theta tapos na squared. So, okay lang guys, i-distribute ko na siya para at least hindi naman natin mapuno yung sulatan. So, in-squared ko na siya, yung ibabaw at ilalim. So, ang kakalabasan natin is ganito. Ayan. So, x squared, and then VO, ito naka-squared, and then yung cosine, naka-squared din. So, ayan. Or our final equation is y is equals to x tangent theta minus, so, eto, distribute ko lang. So, gx squared all over 2 VO squared cosine squared theta. Ayan. So, this is the formula, derived formula for this, yung pagkuha ng y at any distance x. Okay? So, just in case guys na ibigay sa inyo is yung distance x and then given yung initial velocity and yung angle and trajectory ng iyong projectile, makukuha mo na yung y. Or vice versa, if given yung y and pinapahanap yung x, shift solve mo lang to para makuha natin yung distance x. But anyway, sabi ko nga, kahit ito lang tatlong tong sa ulo mo, actually 4. Ayan. So kahit di mo na to, kasi na-drive nga lang natin yan using those relationships. Okay? Next, at point A, ano ba sabi sa point A? At the highest point or summit, where alam natin nga, yung y component ng velocity is equals to 0. So meron tayong derived formula na h is equals to VOY squared over 2g. Or ito guys, sa ibang book kasi, ito ay equals lang saan? Ano nga yung VOY natin? So that is VO squared sine squared theta all over 2g. So siguro nakita na kayo ng equation na to. So maaaring na ituro sa physics. So ipakita lang din natin kung paano siya na-derive. And kapag do sa maximum range naman, ito kasing at point A, diba do sa figure, ito yung may maximum height. Okay? Or yung capital H yung equation. And then, ibaba ko lang. And then do sa point C naman, yung x mo is ito yung maximum range or yung pinakamalayong pwedeng marating ng yung projectile. So, ang value ng y dyan will be equals to 0. And ayun nga, yung velocity niya doon o yung x velocity niya doon is equals lang again sa initial velocity. And yung y component ng velocity doon is equals sa negative VOY. Okay, so yung formula, ito na siya. Ayan. So, siguro nagpangitan na rin kayo nito. So, ginagawa ko dito parang may pattern lang ako eh. Kasi magkamukha naman sila eh, kung titingnan mo. Ayan. So, ang palatandaan ko dito, so parang binaba niya lang yung etong squared. Kaya naging sine 2 theta. And nung binaba niya, so inisip ko para ma-cancel yung 2. Okay, so anyway, i-derive ko rin naman yan. Paano sila nakuha. Okay, so siguro simulan natin dito sa range. So, ang gagamitin nating equation guys is yung na-derive nga natin nung una na equation na ito. Okay? So, ang gawin natin, i-copy na lang natin para at least hindi na natin isulat. Ayan. So, i-paste natin dito. Tamad na, di sinulat. So, dito na lang. Okay? So, using the derived formula, paano mawala? Ayan. So, guys, using the derived formula, again, i-derive natin yung equation for the maximum range. So, para makuha yan, again, alam natin na doon sa point C na yun, or kapag drawing mo yung projectile motion niya, ito kasi yung point C. So, yung hinahanap natin is ito, yung maximum range. So, ano yung value ng y niya dyan? So, diba, wala namang height dyan kasi nga, pantay na sila eh. Isipin mo, ayan sila. Magkapantay na sila. Therefore, yung value ng y dito will be equals to 0. And yung x natin, mapapalitan siya ng value ng maximum range. Okay? So, yung x, magiging r lang. And then, tangent theta. So, ano bang hinahanap natin? Ito yung pinapalabas nating equation. So, anong gagawin natin dito sa tangent theta para makapagkamukha yan? Sige, ano yun natin? Try natin na expand to. Sin theta over cosine theta. So, minus gx squared. So, yung g. Okay, so i-retain natin, g. And then yung x, magiging ano nga lang siya, di ba? R. So, magiging gr squared. Is over, so 2. So, naka-VO squared naman siya, no? So, i-retain lang natin to. Cosine squared theta. So, mangyayari, itatranspose ko tong part na to doon sa kabila. Or the equation will be gr squared all over 2. So, VO squared cosine squared theta is equals to r sine theta all over cosine theta. Okay guys, so i-cancel ang pwedeng i-cancel. So, ito, maa-cancel na to. Ito, mababawasan ng isa, or this will be 2 minus 1. Ano pa ba? So, ito, cancel na natin, guys. And then, ito, mababawasan ng isa. So, meron pa ba? So, wala na, ano? So, our equation will become, so, r, so, raised to 1 na lang yan, is equals to VO squared, okay? And then, 2 sine theta cosine theta. Okay? And then, ibababa natin yung g. Okay, so meron tayong, ano tawag dito sa mga ganito? Alam kasi natin na yung sine 2 theta, di ba kapag in-expand mo yan, trigonometric identities ba ang tawag dito? Hindi ko lang tanda. So, di ba equal siya sa 2 sine theta cosine theta? Ayan. So, since equal siya dun, eto, papalitan natin ng identity na yan. So, therefore, yung r mo can be written as, so, VO squared, so, sine 2 theta all over g. Ayan. So, na-derive natin yung equation na yan. Okay. So, ito naman, ipinakita lang kapag time yung kukunin. So, anyway, ano na lang natin to? Skip na lang natin kasi ito naman yung usually na sinasaulo. And then, ito. So, paano ba nakuha itong equation na yan? Okay, so, para dito sa equation ng h, or ito yung at point A, kung saan nandun nga yung maximum height. So, again, ano nga sabi dito? So, at maximum height, the y velocity is equals to 0. So, ano lang natin dito? Drawing lang natin. Ayan. So, ito yung equation natin. Okay. So, ito yung initial velocity. So, again, ang final velocity niya dito, yung y component, o yung VAY, is equals to 0. Okay. So, ang gamitin nating equation, guys, is yung this one, saan y is equals to VO y t minus 1/2 of gt squared. Okay? And siguro gamitin rin natin ano bang equation ang pinapalabas na? Ito. So, kailangan natin makakuha ng relationship ng time with respect dun sa VO. So, VO lang at saka yung ano, kailangan kong. So, para doon sa mga theta, since VOY nakalagay dyan, so, i-VO natin cosine, sine theta. Ayan. Okay. So, gamitin rin natin tong first equation, itong final velocity minus initial. So, kasi nga, kailangan natin mapilit na magamit to. Ano? So, yung VAY, or yung final velocity, is equals to VOY minus GT. Okay? And knowing na yung kanyang VAY, ito is equals to 0. Therefore, maagawa tayo ng equation or relationship ng VOY, so is equals to GT. So, wala namang time dito sa equation na to. Ayan. So, ang gawin natin in terms of time. So, ang time mo can be written as VOY all over G. Okay? So, yung time natin dito, isa-substitute lang natin sa equation nito. Ito, yung first equation. Or our equation. So, again, yung Y natin is mapalitan na yan ng H. So, is equals to VOY. So, puro sign yan. Wala namang Y dyan. So, kunin natin siya with respect or in terms of VO. So, paano nga makukuha yung VOY? So, that is VO, initial velocity times sine theta. And then, multiply by time. So, ito nga is VOY din. Or ito can be written as VO sine theta all over G. Ayan. So, VO sine theta all over G. Okay, so okay lang. So minus 1/2 of G times time squared. So ito, PO sine theta all over G. Tapos naka-squared. May G rin dito. Cancel. Ah, hindi. Sige, sige. Tama. So, magiging ano siya? So, VO squared. So, sine squared theta all over G. Then, minus 1/2. So, ito, G. And then, ito, VO squared sine squared theta all over G squared. So, pwede kong i-cancel na. Cancel na guys natin to. And ito, ma-minusan ng 1. So, parang nangyari dito, since common yung VO squared sine squared theta over G, so parang naging 1 minus 1/2. Or ang matitira na lang sa'yo, bako lang ng kaunti, is ito na. So, H is equals to VO squared sine squared theta. So, 1 minus 1/2, so magiging 1/2 over 2G. Ayan. So, na-derive natin. Okay, so guys, ito lang yung mga equations na gagamitin natin. Again, kita nyo naman na madali naman siyang i-derive and ayun nga, ginagamit lang din talaga natin yung mga equation na to which is nanggaling lang sa free fall at saka rectilinear translation. Kaya, sabi ko nga, kahit hindi nyo nasaulin kasi ayan lang naman yan yung relationship. Basta maurulong ang kumuha ng component at alam mo na yung mga bagay na kailangan dapat alam natin. Na dapat constant yung velocity, yung x component niya, all throughout sa iyong trajectory. And yung y component ng velocity pagdating niya sa maximum height is equals to 0. Alright, so I think it's better and mas ma-appreciate nyo siya kapag nag-solve tayo ng mga problem. So let's start first with, ito pala. Note, mahalaga rin to. So by is positive if directed upward and negative if directed downward. Okay, so same lang din naman sa ano natin, free fall. So sabi nga, if yung by mo is positive if directed upward. Okay, so kung sabay sa direction ng initial velocity, and negative if directed downward. So kapag pababa na siya. At any point d below the origin, the sign of y is negative. Okay, which is correct naman kasi yung point dito sa figure, ayan. Nasa baba na kasi siya ng initial ano eh. So kapag sumukat ka dito ng y, ayan. So, since pababa yan, yung y mo is negative y. Okay? So, itong mga values na sa taas, ayan. So, puro positive yan kasi sabay sa direction ng initial velocity. Wala naman yatang projectile na pababa. Sige, tingnan natin. If I'm not mistaken, alam ko wala. Sige, i-try natin sa mga examples. Okay guys, so let's start with the first problem. So, basahin muna ulit natin. So, a shell leaves a mortar with a mass of velocity of 150 meter per second and it is directed upward at 60 degrees with the horizontal. So, meron ka daw ditong mortar. Ayan. So, it has an initial velocity of 150 meter per second and it is directed upward. Ayan, so yung angle of inclination niya is 60 degrees with the horizontal. So determine the position of the shell yung bala niya. So gawa lang tayo ng projectile projection niya. Trajectory. Okay, so determine the position of the shell and its resultant velocity 20 seconds after firing. So how high will it rise? So dito sa last question, so most probably ang pinapahanap niya dito is yung maximum height, h. Okay, doon sa h, ipapakita natin yung dalawang way para ma-solve siya. Pero ang hinahanap lang naman dito is yung position niya after 20 seconds. So, let's just say guys na after 20 seconds, i-assume natin na siguro nandito siya banda. So, gawin natin siya velocity. Position A. Okay, so gawa lang tayo dito ng reference line. Ayan. So yung reference line na yan, dyan natin ibabasa yung mga distances. Sulat natin to as distance x. And then this one, so this is our distance y. So unahin muna natin yung pinakamadali, yung x. Again, kunin muna natin yung mga component ng velocity. So for the x component of the velocity, that is simply equals lang sa 150 cosine of 60. And for the y component, so that is simply equals lang sa VOY or 150 sine 60. Okay, so to solve for x, again, ang velocity niya, pagdating niya dito sa point na to, napalabis pala ako dito. Hindi, tama pala. Nandito nga pala siya. So, velocity niya all throughout sa trajectory mo is equals lang, yung x component niya. So, that will be 150 cosine 60 and then multiply by the time, which is 20 seconds. So, kunin ko lang yung calcul. Nasaan ba yung calcul? Ito. So, that is 150. Nagkang yung calcul. Wait lang. 150 cosine 60 times 20. Ayan. So, nakuha natin yung unang pinapahanap. So, that is 100,500 meter. Okay. Next, how about the position y? Okay. So, for the position y, since meron na tayong value ng x, ang pwede kasi natin gawin dyan is gamitin natin yung derived formula. So, yung derived formula ulit natin na gagamitin is ito. Yung y is equals to x tangent theta minus gx squared over 2bo squared cosine squared theta. Pero pakita rin natin using this equation. Okay? So, unahin muna siguro natin ito. Mas gamitan natin ng derived formula. So, to get that y, so again, that is equals lang sa VOY, or that is 150 sine 60, and then multiply by the time na 20. So, minus 1/2 of g na 9.81, and then 20 squared. So, what is the value of our y? So, that is 150 sine 60 times 20, and then minus 1/2 of 9.81 times 20 squared. So that is 636. Okay, 636.0762. Okay, so alternative solution. So using the derived formula. Derived formula. So to solve for y, so again that is equals lang. So ano nga yung formula yun? Hindi ko rin masyado sa ulo. So that is x tangent theta minus gx squared all over 2 initial velocity VO squared cosine squared theta. 2VO squared cosine squared. Ayan. So, check lang natin since meron na tayo nakuha ng value ng x, which is 1,5. So, gamitin lang natin siya. So, 1,5 of tangent. So, 60. And then minus 9.81 times 1,500 squared all over 2 times the initial velocity na 150 squared and then cosine squared of theta is 60 degrees. So, verify lang natin guys. 1,500 tangent 60 and then minus 9.81 times 1,500 squared. So, divided by 2 divided by 150 squared divided by cosine 60 squared. So, ganun yung pag-type ng cosine squared theta, cosine 60 squared. Ayan. So, 636.0762 rin. 636.0762. Alright. So, pareho lang, di ba? So, either of these two, kayo nang bahala kung ano yung mas preferred nyo na equation. Okay, so next, alamin natin yung final velocity niya. So, again, ito kasing velocity mo dito at x direction. So, equals nga lang siya dito sa VOX na 150 cosine 60. So, problema na lang natin is yung y component niya or yung BAY. So, yan yung unknown natin. Okay, so since meron naman tayong value nito, so ano mo yung gusto nyong gamitin natin? So, siguro mas maganda if gamitin na lang natin yung BF is equals to VO. So, minus GT. So, since pababa na yan, so ito is minus, so BF. So, ano ba yung VO natin? So, initial velocity. So, 150. Kaso ito nga, is dapat ito yung VOY. So, that is 150 sine 60. Kasi puro y component yung pinag-uusapan natin. Kaya, ang VO natin dito is yung VOY. So, minus 9.81. Then, times, ano na seconds to? 20 seconds. Okay, so what's the final velocity? So, that is 150 sine 60 and minus 9.81 times 20. So, that is negative 66. So, cancel lang siya. Kasi, inano nga natin siyang pababa. So, to 66.29. Ano yun? 62. That is in meter per second. So, this is downward. So, to get the velocity at point A, sorry, baka lang malito ano. So, yung final velocity natin dito, i-denote natin siya as kung ano yung velocity dito. So, this is BAY. Okay? So, to get the velocity A, ayan. So, to get that velocity A, so that is equals lang sa VAX squared plus VAY squared and then square root A. Okay, so pangit. Ayan. Shoot, nakalimutan ko mag-store. So, answer squared plus, nasan yung velocity? 150 cosine 60 squared. The square root of that answer. So, 100.1. Anyway, it's most probably rounding off lang yan. 100.9. So, meter per second. Okay. And then last, ano ba yung required? So, hinahanap yung maximum height na yan. So, again, meron naman tayong derived formula dyan. So, I think it's better na i-apply natin. Kasya pa ba? Okay. i-apply muna natin siya, ano? Tapos tsaka natin gamitan nung ano, yung analysis lang. So yung h niya, ano nga yung derived formula natin for maximum height? So, silip tayo sa Odigo kasi nga ang alam ko ay yung mano-mano. So, BOY squared over 2G. BOY squared. BOY squared all over 2G. Tama ba? Okay, over 2G. Okay, or this can be rewritten as yung ano nga, BO sine theta. Ayan, naka-squared pareho. All over 2G. Okay, so ilagay lang natin yung mga value. So 150 squared sine squared 60 all over 19.62 or 2G. So, ganun rin naman yan. So, lagyan ko lang guys ng mga boundary ha para at least hindi nagkaalituan sa solution. So, para pag kinopyan nyo. Ayan. So, what is H? So, pindutin lang natin. So, 150 squared sine 60 squared divided by 19.62. So, 860. Ayan, lumabas naman. 860.0917. 860. So, 860.0917. Alright. So, napalabas naman natin lahat. So, tingnan lang natin. Gawa natin ng alternative solution yung pagkuha ng y. So, again, doon sa maximum height nga ulit, ano nga yung dapat alam natin dito? So, ang V, sabihin natin to as point P. Yung BBY mo will be equals to 0 and ang meron ka na lang dito is yung BBX which is equals to yung BOX na 150 cosine 60. Okay, so ang ano natin dyan is ano yung time na para pakapunta dyan. So, ilat natin lang to as our okay, so I think mas applicable dito yung botox na formula. So, again, ano nga yung ating isang formula, yung naka-squared. So, di ba yung velocity at point B. So, BBY squared is equals to BOY squared. And then minus 2G. Tapos yung H, which is yung unknown. Ayan. So, knowing that yung final velocity natin dito sa point na to, again, yung BBY mo is equals to 0. So, 0 is equals to, so, ayun nga, 150 sine 60 squared. So, minus 19.62 times H. Okay, so yung H natin is equals lang sa 150 sine 60 so squared divided by 19.62. So that is 860. Ayan, kuha naman natin. 860.0917. Okay guys, i-analyze ko lang din ano. Kasi yung point A, nag-assume lang kasi ako ng direction na nandito siya banda. Actually, pwede kasing before pa siya sumapit dito sa ano. So, paano natin siya malalaman? So, alamin natin yung time required para ma-reach niya yung maximum height. Okay? So, kung makuha natin dito is, for example, 32. For example lang ha, yung time para ma-reach niya yung maximum height is 32. So, ibig sabihin, mali pala ako ng assume dahil dito ko siya nilagay. So, again, ang in-assume ko, dito siya pupunta after 20 seconds. Pero since, if ang mapapalabas kong time dito, para lang ma-reach na yung maximum height is 32, ibig sabihin, lumampas pala ako. So, dapat andito pala siya. Pero once na nakuha ko dito is less than. So, tama naman. Reasonable na naman na dito ko siya nilagay. Kasi nung na-reach na yung time, for example, 16 seconds. So, kapani-paniwala naman. Kasi nandito na siya after 20 seconds. Okay, so how can we solve for the time here? Siguro pwede na yung ayan, yan muna pala. So, yung final velocity is equals to initial velocity minus gt. Kung saan yung final velocity nga natin dito, or yung BBY mo, is equals to 0. So, kailangan na lang natin dito is yung BO, or that is 150 sine 60, and then minus 9.81 times time. So, we will have here the time. So, 150 sine 60, and then divided by 9.81. So, 13.242 seconds. Ayan. So, what can we conclude if 13.242 seconds lang yan? So, tama. Yung assume natin na nandito siya banda. Okay, guys. So, I'll give you 3 minutes to copy this problem. Zoom out ko lang. Kita ba doon sa OBS? Dito na sa banda solution na. Ayan. Ayan, kita naman. Sige guys, I'll give you 3 minutes. So, please start copying. Sige, habang nakakopya kayo guys, paano kung ipahanap bigla? For example lang, sige, kopya lang. So, kung ipapahanap guys yung x distance o yung horizontal distance nung na-reach niya yung maximum height. So, madali lang yan, So, ilat na lang natin to as distance m. So, to get the distance nung na-reach niya yung maximum height, again, that is simply equals lang sa SBT. Kasi nga, wala siyang acceleration. So, yung S mo, that will be just equals to sa M, distance M. Or yung M is equals, again, yung velocity niya is constant all throughout the trajectory ng projectile. So, that is 150 cosine 60. And then, i-multiply mo lang ng time na nakuha natin, which is 13.242. So, mahanap mo na yung distance traveled when it reaches its maximum height. So, asan yan? So, 150 cosine 60 times 13.242. Ayan. So, 993. 0.15. Okay, so distance traveled when it reaches maximum height. And if pantay lang naman guys yung case mong ganyan, kumbaga level lang naman yung ground. So yung maximum range niya, eto, i-multiply mo lang ng 2. Kasi tingkalahati lang yan. And ganun lang din sa time. So multiply mo lang din ng 2. So, mas madali naman talaga guys if sa ulo nyo yung derived formula. Kasi direct substitution na naman talaga siya. Pero yun nga, just in case na makalimutan, may option ka pa rin naman. As long as alam mo yung principle ng rectilinear tsaka free fall. And yung rule nga sa sa projectile motion na yung x velocity niya is constant all throughout the trajectory. And yung y component ng velocity sa maximum height is equals to 0. So, yun lang yung panghawakan mo dun. And the rest is, yun yan, naituro naman sa mga free fall. Malaga rin dun yung direction ng basta sumuway ka doon sa direction ng yung initial velocity, negative siya. Iba't iba sa kasi iba't ibang book yung sa mga book iba't iba kasi yung approach nila. Merong hindi ganun yung tapos hindi ganun yung rule, tapos doon sa isang topic biglang ganun. So ang ginawa ko, ayan nga, since ganito sa projectile, in-adjust ko na rin yung sa and yun din yung tinuro sa amin before ng instructor natin, si Mamun. So tanda ko pa rin siya hanggang ngayon. Okay guys, yung next problem, iano natin sa second session natin. So siguro 2 or 3 more problems. Yung sunod na case, yung mas mababa or yung pinagagisan niya mas pataas doon sa papataan. So bibigyan ko rin kayo ng case na nasa inclined plane siya. So lahat ng possible case under this siguro 3 or more pa. Okay guys, so see you guys on our next video. Thank you.